right, thanks for coming out today. Looks like we've got a nice crowd, and it's a pleasure to present here in my hometown. So the topic today, compute. It's kind of a really general topic, but first a little about me. I'm a AWS certified solutions architect, associate level. Been working with AWS somewhere around 9 years or so. Just recertified last year. I'm a lead application developer with Deline Consulting. Deline Consulting is a nationwide consulting company. They primarily specialize in FileMaker, Salesforce, and web development. I've been involved in architecting our hosting offering, which we're calling Deline.cloud. And then we're trying to branch off of there and adding a whole AWS practice to our consulting, which is exciting. Okay, jumping into the compute. Why AWS compute? And we've probably all seen this graphic before, right? This slide, the Gartner Magic Quadrant, right? And you can see AWS Services all the way up in the top right corner, which is where you want to be, right? Microsoft's up in there, and you've got a bunch of others kind of in the other quadrants. The thing I like to point out about this graphic is the different metrics that it's using, completeness of vision, ability to execute, are a little bit fuzzy. So to me, this is kind of out of scale. To me, AWS actually is a lot further out than others when you consider their global infrastructure, right? Their networking that's grown all the time and grown at a rate that the rate may not match some of the others, but when you consider the expansive base that they already have, their continued growth year over year is impressive, right? They're constant market leader. Something that I thought was interesting was their overall infrastructure capacity is 10 times the next 14 that appear here on this chart. So just to give you an idea of like how far out ahead they are. And a big advantage to going with AWS is the lower upfront cost. So a lot of times this is kind of the hook to get people in, but it's the ease and just the overall expansiveness of the tools that keep people around. So when I mentioned their global network, and I mentioned this just to put the compute into context, right? Compute sits on top of this global network. And I actually gave part of this presentation a couple years ago at a FileMaker Developer Conference, and I had to go back and update some of these slides. So it's interesting to see how some of this has changed. You know, back then there were 16 regions, now it's 21. Back then it was 44 availability zones, and now it's 66. So I just wanted to mention this. It's really interesting to me hearing some of the different AWS engineers talk about their network. Like this sits on top of an Amazon-built network. So you're not going out to other telcos and stuff. It's all in AWS. And that includes like some transoceanic cables that they've laid. So what's a region? A region is comprised of 2 or more availability zones, right? So what's an availability zone? An availability zone is 1 or more data centers, right? Discrete data centers that are secure and interconnected with redundant power and networking. It's at least 2, and the new standard as they open up more regions is 3. An interesting thing that I thought about an availability zone is you could think of an availability zone as just a series of racks and cabinets, right? They're all in networking gear, but they kind of cap off how large they build an availability zone. They typically are around like 50 to 80,000 servers in an availability zone, and then instead of building just a bigger availability data center, they'll build a new one and expand their region that way. And I mentioned that it's kind of interesting because it's that kind of forethought that goes into, I don't have to think about rack and stack and all the configuration. They do that to, limit the blast radius in case there is a power failure. It doesn't affect, a whole lot more servers. And then edge locations. I don't know the exact number, but those are kind of your regional caches and where you have like Lambda at edge. This reduces greatly the latency between like your network and stuff to end clients. Right, and there's like a picture of an availability zone just to give an idea of like, the security involved. So why infrastructure as a service when we're talking about compute? I like this slide because it kind of illustrates how, I'm old enough, I come from a background of where, we had to provision cabinets and had to request purchase orders for servers, rack and stack them, do all your networking gear. So if you look at the blue line on there, and even kind of the gold line, right, that kind of represents the old way of doing things, where you had to have this initial capital expenditure, buying equipment, planning for your actual demand, which you can see by the red line, right? And if you didn't guess right, you get into a situation where you're under provision, you lose customers. So this green line kind of represents, this is a new way of doing things, where this on-demand cost, it's not even virtualized servers, right? Because you can buy equipment and do the virtualized server, but you're still paying that cost. You still got to provision for it. But in AWS, it's a pay for what you need kind of model. So you can adjust up and down. When the demand dips down, you can match that demand and not continue to pay for it. So scaling up and down, that's a big infrastructure as a service. So the big 800-pound gorilla in the room when you talk about compute is EC2. EC2 is kind of where the rubber meets the road, right? It's the backbone of AWS. So these are Windows and Linux virtual machines available in different sizes and types. And the E in EC2 means elastic, right? And that's the scalability we just talked about, scaling up and down. So different instance types. What do we mean by different instance types? So we kind of break down. These are the different, or how to read the different instance types. Right. The first letter in it is your general instance type, and these are different types of computers depending on what kind of workload you're going to be deploying on there. So T is general. C, compute, memory, and there are a bunch of different, and they keep adding more instance types over time. Right, the second digit in there, the 2, that refers to the generation for this type, right? T2 is common. T3 you see more and more, and that's available in most regions now. And that refers to, there's difference in the underlying architecture, the type of processor that it uses, type of memory, and the different capabilities of that generation. And then finally, you've got a general T-shirt sizing, so the large, X-large, small. And that refers to the number of CPUs available, the amount of RAM available to that compute instance. Right, and then your pricing is dependent on the type of instance and the size that you give it. In general, T's the lowest cost, and that makes sense. So a little bit more continuing on about compute. We've got auto scaling and elastic load balancing, which kind of go hand in hand, but they're two different things. Auto scaling refers to you can provision, you can set up a set of rules, say when your demand rises, to automatically build up new instances to match your demand. And then at the same time, when your demand goes down, it'll tear down those instances, and you save cost. You only pay for those instances while they're up and running. So you can configure those instances with user data, right? That's like scripting that is built into those instances. So when it comes up, you run, say, like a shell script or a PowerShell script. It's going to configure that machine to do exactly what you need, just on demand. And elastic load balancing kind of goes hand in hand with the same concept of auto scaling, but It's going to provide like a single endpoint and do your load balancing. And this is configurable too, depending on the type of load balancing you need. So the popular example is, Netflix when they started out was, they used auto scaling and elastic load balancing. So at 6 o'clock in the evening when people got home and switched on Netflix, these rules would kind of kick in and build up more machines. And then 11, 12 at night when people went to bed, it tore all those down. So there's a huge cost saving when you get to you don't have to pay for your peak demand at any given time. Spot instances. Spot instances are real interesting. The concept is this: you only want to pay for a server when the price to run that server goes to a certain price range. So AWS offers up these different instances. So during the evening and stuff, as the cost to run an instance goes down, right? Power costs go down at night. They make these instances available to you, and you can place a certain bid. Say when the price goes down to a certain point, spin up these servers, do what they do. When the price goes up above it, right, stop them. I don't want to pay for them anymore. So this has got a huge impact on, especially compute-intensive stuff. Like universities use this for research all the time, where they've got a lot of things to compute, but they want to manage those costs. So they can set a budget for that and use spot instances to manage that. And they've introduced a service called AWS Batch that helps manage those spot instances. And then Lightsail, I'll mention here briefly, Lightsail is kind of like your EC2 starter edition. So it's kind of like, all this EC2 stuff, there's a lot of complicated moving parts and stuff. I don't want to do all that. Just give me the basic, I just need a server, flat monthly cost. Lightsail is kind of the way to go. It's still all underpinned by EC2, and there is a path to upgrade to EC2 from Lightsail, but it's just to make it easier to get into that. So it'd be hard to mention EC2 without digging into a little bit VPC and EBS. VPC, the virtual private cloud, this concept kind of came about because a lot of AWS customers, what they really wanted to do was to link up their on-premises network by VPN to their cloud infrastructure. And to do that, you really needed some kind of virtual networking to go along with that. So that's where VPC started. It's totally managed virtual networking, right? They give you one by default. You may never branch off and build up your own VPC. The one that's there by default, it matches along with the range of private networks that things should be in, which is what they recommend. If you're familiar with CIDR routing rules, it's like the /16, which gives you around 64,000 addresses, right? Which is good, which should be plenty. Question? Sure, go ahead. Yeah, so the question was, if you're setting up a VPN to a VPC, do you need to set up a site-to-site VPN or direct connect? And the answer is, you could do both. Yeah, depending on your needs. Direct connect's gonna be more expensive. Site-to-site could be a lot more practical. And then there's other options too, like Cisco has different appliances out in the AWS marketplace where you can have that act as your VPN router. So, elastic block storage. Block store, I know this isn't the session on storage, right? It's the session on compute, but we need a hard drive to run our operating systems, and to do that, you need block storage, right? I will note here that the pricing applies to stopped instances too. So whatever you provision, as long as it's not ephemeral. Ephemeral means like it goes away when your instance stops. As long as the EBS storage stays around, you're going to pay for that EBS storage, even if your instance isn't running. A little bit more about VPCs, right? The concept of SDN, software-defined networking. So they've made it really easy to administer these networking rules, especially if you're familiar, if you come from a networking background. This is kind of a nice, like, easy way. I remember the first time I set up a server with a colleague of mine, went through, and about an hour we set everything up, and at the end he kind of sighed and said, "That was the easiest server I've ever set up." So these are applicable in each VPC. Each VPC needs to live in a region, right? So every region is kind of sequestered into its own VPCs and stuff. And if you need to peer across, then you can set those up. Right, and I don't need to, I hate to go in and explain CIDR notation, right? But it's there if you want. Yeah, question? IPv6, good question. What's the importance of IPv6? Well, it is supported on most of AWS services now, and it's definitely supported in EC2. The difference, in case you don't know, like IP4, you're limited in how many IP4 addresses you can assign. IP6 is basically everybody gets an IP address. You know, it's kind of like the Oprah show. Like, you get an IP6, you get an IP address. So there's no difference. There's no difference on your local network and the wide area network from your IPv6 address. But it is kind of limited to applications that support IP6. So I think we still kind of live in an IP4 world, but that is something to, future-proof. So S3, I mentioned, yeah, this isn't the storage talk either, right? It's the compute. But again, there's a lot of crossover. You're going to be storing a lot of resources. And the one that I will note, EBS snapshots are stored in S3. They don't show up in a particular S3 bucket, but they are stored as S3. We'll talk a little bit more about this. So we'll go back in time a little bit. And for a while they had what's called EC2 Classic, and this is the way they started out, right? It's you want an instance, you get an instance. It's kind of like the concept of VPS, your virtual private server. And everything's an instance out there on the internet. Here's your computer. There you go, right? This is not the way we're doing things now. So an example how we would set something up in a VPC, right, in a particular region. Maybe we got some resources out there. We create a VPC in a particular availability zone, and we set up our server in a security group. We need an internet gateway. We need a way to get out to the internet, right? And those are easy to attach to your VPC, and there you go. So a little more complex example. Still not that complex, but right, here's some other options. Maybe we have a VPC, and we'll set up an availability zone, and say we want this to be a private group, right? So it's not going to be directly accessible from the internet. We want, say, our database server and application server in that group. And then we want to connect that to our corporate data center via site-to-site VPN, right? That goes directly to that network. Maybe we want a web security group set up in a different, in the same availability zone, but in a different security group. And that one is going to have access out to the internet to be accessible by clients out there. And maybe we also want to add some VDI kind of infrastructure or virtual desktop for our corporate clients to connect to, right? And they connect directly to the application server. And maybe we want another like backup. So again, not the most complex scenario, but just to give you an idea of like these are the kind of things you plan out when you're building your infrastructure. So a couple of other concepts to mention, reserved instances. I go back and forth. I don't really like the name reserved instances, but the concept is this. You're basically signing a contract for I'm going to use an instance for this amount of time. And they range in from terms from a year up to 3 years. So if you know you're going to use an instance at a particular size, it's a good idea to, you can get quite a bit of cost saving from going with a reserved instance. Cost monitoring, it's easy for cost to get away, but it's also real easy to go in and set up a couple alerts so that you know when you're passing a certain threshold, if you need to maintain those costs and really keep a close eye on that. We do a lot of that. Tagging too. Tagging is a good way to partition out, resource manage. We use them a lot for cost allocation. So we'll tag everything. That way we know by looking at the billing report where we can associate things back to. And I can show you an example of that in a minute here. So going into Selenium Consulting, Selenium.cloud, how we utilize the compute services. Right, we pretty much have these custom AMIs that we build up server instances with. One of my colleagues, he actually worked for Microsoft, Apple, worked for FileMaker for over 10 years. So we really have a good idea of how to provision these servers for our clients. And I know like FileMaker is kind of a niche, but that's kind of our thin edge of the wedge into AWS, right? And we've been pretty successful at it so far. So extending a lot of the functionality that you get out of that general architecture, right? And that's something, one example of that is something we call Snapbacks. I'll show you here. Right, and you can see this is kind of our custom application, and up to the day, we can see where our billing is per instance. So what's a snapback? Snapback is something we came up from to provide some extended functionality, right? For doing, the concept is a snapshot plus a backup, right? And normally a backup, it would have to write out to a volume. And if you've got a large database, that can take a lot of time. So utilizing snapbacks or snapshots in AWS with the system that we put together has been pretty beneficial. So here's the interface that we have for that, right? We can set a custom retention policy, right? And based on that, say I want list out all the snapshots that are out there in AWS, right? And say I'll click the third button down. So now what's happening is there's some scripting going on behind the scenes. It's going to create a volume from that snapshot. Remember, snapshots are stored in S3, so the cost is a lot less than EBS, right? So we create a volume, an EBS volume, attached to the instance, assign a drive letter, create the virtual directories in the operating system. And when it comes online, we see that. An email goes out to the client. They connect via FTP, and they've got access to all their backups. So it allows them to have a lot more backups for their database than would ordinarily, like it would be cost prohibitive to have that many in block storage, right? And then the same thing, when they're done with it, click a button, it tears all that down. That charge goes away. They only get charged for the time that was attached to the instance, right? And we track all that through tags. So here's some other services that we use. Route 53 is a good one to mention here in particular because you don't necessarily need a public domain. You can use these in your VPC with your EC2 instances. You can make up whatever domain you want, and you can manage domains easily in Route 53, right? Another neat one to mention here is AppStream, which we've done for a couple clients. AppStream is kind of it allows you to present like a Windows desktop, and it's all in a web browser. So it's kind of impressive. It's kind of like the old Citrix farm, but clients don't need any special software. They just use a HTML5 web browser, and they get like a full desktop experience. And again, that scales up and down automatically. You could set rules as your application needs it. So We also utilize something in AWS called organizations. And this has been a real good thing for us going forward as we branch out into, we're working a lot more closely with our web practice. So when you set up consolidated billing in AWS, it allows you to manage multiple accounts. And you automatically get benefit of economies of scale, say like your reserved instance prices, they will apply across all accounts. So this allows you a way to set up, say you want kind of a sandbox environment for development, and you want developers to be able to go in and explore all these different AWS things, right? Kind of feel out what the project needs and not be constrained to them messing up anything in your main account, right? So it's also a way of limiting the blast radius, what can be done. And then when you're ready to deploy, that can be deployed to another account. So you can see, all that comes through in our reporting. I'll point out a couple here. So even though like we're not a Lambda shop, like our web development team, they're getting into it and they can do all that stuff, and we just, we're still able to break out those costs and associate them to a client. So, kind of going back to our compute discussion, Lambda, if you don't know Lambda is serverless computing, right? It's event-driven computing. So the idea here is, of course, it's not completely serverless, right? That's just a term. The meaning is you don't have to provision a server. You don't need to maintain an operating system, anything like that. You're just, executing some code somewhere. The big benefit is that can automatically scale according to AWS's overall infrastructure. So you've got a huge amount of scalability. You don't have to worry about auto scaling servers and stuff, right? It's just this code, and they're gonna take care of the availability, fault tolerance, and automatically scale that code for you. So more and more development is gonna be going this way, right? It kind of started out like you have to buy servers, set them up, and then it went to creating virtual servers. Now it's all infrastructure as a service. And then the next step is let's get rid of the servers completely, right? EC2 I think is billed down to, used to be the hour, I think it's now down to the minute. These Lambda functions are actually billed down to the 100 microsecond increments. And then I also mentioned EC2 container service. If you're familiar with Docker and how that works, and Google's flavor of it is called Kubernetes, right? And they just branched off, and that is in AWS as EKS, right? It's the same kind of concept, though. Containers, basically the concept is instead of virtualizing the entire machine, you're virtualizing, say, different components. So say like you just virtualize Apache or your database portion, and you manage those as containers. And Fargate is also their AWS is like their managed service for managing containers. So that kind of rounds out, I think, all the compute offerings in AWS. And then I like to finish up always by mentioning this. I think it's a real good white paper. They've actually broken it out into like 5 different white papers, and you can drill into each of them separately, this well-architected framework. And this has been a good blueprint for us moving forward, looking at those different five pillars, that it's based on operational excellence, security, reliability, performance efficiency, and cost optimization. So those are good, guidelines to follow along. Okay. Any questions? Any follow-up? Anything?
Any questions for Mike? I'll bring the microphone around. That way we can get it on the recording. Actually, there's people on live stream too.
Okay.
I have a question.
Yeah.
The instance types, you went over kind of like general, and then the various generations, and then the t-shirt sizing. You mentioned CPU and memory, but it sounds like it seems to me like it also limits maybe the amount of I/O and network bandwidth you have available to those instances. What has been your experience with, like, say, a medium versus a large versus a 2x versus 8x on like I/O?
Yeah, good question. Most of our workloads are happily suited in the T2, T3 workloads, and we don't see a whole lot of spikes in there. We do monitor that. Because those instance sizes, of course, like you pay for if you spike above a certain percentage, but we haven't seen that to be a problem. There are some, you talk about I/O, especially in terms of like input output per second. Those are more related to like EBS volumes. So I didn't mention there are different types of EBS volumes. If you want a higher input output, there is kind of an algorithm that you go through. You can provision like a larger EBS volume to get a little bit higher IOPS. And if you need to go higher than that, they also provide for something called provisioned IOPS. So you can pay extra to get like a higher cap on those.
All right. No one else has questions. I'm going to keep going. I got more questions. What's been your experience so far using the new AMD instances, and have you tried the new A instance types?
I have not, so.
All right. Any other questions for Mike? All right. Well, I want to give Mike a big round of applause. Thank you for coming out and being part of IndyAWS today.